Lody, jo. Dobrý.
Hello everyone, welcome to our next lecture which will be held about blockchain analysis. And please welcome our next speaker, Jiří Kremser.
Hello everyone, let me introduce myself. Can you hear me in the back? No. Cool. Let me introduce myself. I'm Jiří Kremser. I work for Red Hat in a team called redanalytics.io, and we develop tooling for develop. Yeah. Is it still? Is it better now? Is it better now? Oh, good point. So yeah, I work for Red Hat in a team called redanalytics.io, and we develop tools for helping developers with intelligent application. We mainly focus on Apache Spark. In this presentation, I will tell something about blockchain and blockchain analysis. Yeah. Oh, sorry. However, now is it better? Cool. So here is the brief outline of the presentation. I will tell something about blockchain, specifically about the Bitcoin blockchain, just the basics, and then how to represent the transaction as a graph, and also how to process this graph in Spark. And the substantial part will be demo using OpenShift. Who of you haven't heard about blockchain during last month? Haven't, yeah, because honestly, it's overhyped technology. I don't care about whether to buy or sell. I would just describe the technology. I don't care about politics. You know, it can be used for society or against. So I don't care, just the technology. So what's the blockchain? It's distributed ledger system. It boils down to just the linked list. So it's a list of blocks that are connected to each other. So each block has connection to the previous one. And the consensus works in a way that each node in the blockchain network holds the whole copy of the network, of the blockchain. And the miners, aka the actors in the system who lend their computing power, tries to put security into the system by a process called mining. It uses heavily cryptography. For instance, all the public addresses are fingerprints of public keys, and only those people who own the corresponding private key are allowed to send the money from that address. Yeah, so as I said, it's a list of blocks. So what exactly is a block? It consists of transactions. That's the main part of the block, is the transactions. But also there are some metadata, like a magic number, which identifies the network. If this comes, for instance, there are different kind of blockchains. For instance, Namecoin is different. Cryptocurrency has different blockchain. So this magic number identifies the Bitcoin-compatible blockchains, because there also exist completely different technologies. For instance, IOTA or Ethereum is slightly different. So if it is only a little bit different, this magic number identifies the type of the network. Also, there can be a testnet. There is a block size argument or attribute. Today, the limit, the size of the block is 1 meg. So depending how big the transactions are, I mean, these days, like 500 transactions are in each block, but it depends on the size of the transaction. It also has the link to the previous block, and also something called nonce. The nonce is a random number which was used for solving the mining problem. The mining is essentially finding such a number that when applying hash function, in case of blockchain is SHA-256, to all of this data, plus the random data that is being generated in the mining process, that if the target value falls into some target, which start in the hash which starts with a lot of leading zeros, we solve the mining problem and we are rewarded as a miners with some reward. These days it's 12.5 bitcoins. So this is the main incentive for miners to do the mining. The other one is the fees for transaction itself. Yeah, and the main part is the transactions. So how it works, like in the conventional system, when I want to send my money to my mom or whoever, there is some bank that holds the account, holds the credentials and everything. For instance, some Oracle database or I don't know where. But in Bitcoin, it's different. When Alice wants to send money to Bob, she wants to create a transaction first using some piece of software, mainly wallets. It's called wallet, or hot or cold, depending on what she uses. And so she creates this transaction, and once it is confirmed, so it means that if there is a miner who takes this transaction, put it in a new block, and finds these nonce, it's considered as done. So as you may see, Alice has 1 Bitcoin, Bob has nothing, so he's sad. So she sends him 0.2 Bitcoins. But the thing is that she has to spend all her money. So she has to send this amount back to her. So as you see, this is the address of her. So in normal conventional systems, we can send only fraction of our balance. But here we can, each transaction, we have to spend all the money in the transaction. We can send it back to us. So if we do that, Bob is happy. This is happy Bob. But this is the simple transaction. This is the more complex one, because the transactions can contain multiple inputs and multiple outputs. And these inputs are connected to the previously unspent outputs. So this is how it works. This is the previous transaction, this is the new one, and this input is connected to this output. So in general, we have multiple input transaction and multiple output transaction, and we want to somehow generate the graph on which we want to perform some analysis. So my first shot was creating bipartite graph, where I connected each input with each output, because it was difficult to say like who contributed to whom. And as a format, I used Apache Spark file, which is good because it's columnar and is natively supported in Spark. I've developed also a tool called Parquet Converter that takes the Bitcoin binary format and creates this Parquet file that can be used in the notebook I will show you later. So this is another approach I've chosen. This is because before we lost the data about in which transaction it appeared, and also in which block it appeared. So this approach is slightly more descriptive, because we have also nodes in the graph representing the particular blocks. And in these nodes, we have timestamp when it was mined. Yeah, it's more suitable. And also we have balances on the amount of satoshis that were sent on the edges. How to process the graphs in Spark. I don't know if you're familiar with Spark. It's a distributed system mainly for ETL stuff. But it also contains a module for processing graphs called GraphX. This is in the core of the Spark, but there is also something called GraphFrames, which is external module that can be used for accessing the graphs. These are slightly different. For instance, GraphX uses a concept called RDD, Resilient Resilient Distributed Datasets, while GraphFrames uses data frames, which are optimized before querying, before executed. There are a lot of built-ins in that libraries, for instance, for finding PageRank, finding triangles, breadth search, etc. And on GraphFrames, there exists a simple ASCII-like language called Motif. It is inspired by a language called Cypher from Neo4j database. And this is not in GraphX. On the other hand, GraphX contains a tool or math computing model called Pregel that allows us for creating new graph algorithms using simple method. We describe like when each vertex can communicate with his neighbors, and we describe like the preconditions, postconditions, and what should contribute to his neighbors. And using those simple rules, we can achieve more complex stuff. So this is Apache Spark in a nutshell, in the architecture. So there is always something called driver. That's something that puts the code for the processing. And there is one master and multiple workers. And master node takes the program from the driver and schedules the tasks on the executors. I'm showing this graph because in the demo I will be spawning masters and workers, and the driver program in our demo will be Jupyter Notebook. Okay, so let's do the demo. Oops. Can you read the font? Yeah, you have questions so far? Any questions? Cool. So first I need the cluster, Apache Spark. So I'm using external OpenShift instance. There is nothing in there, so I can use either UI tool, web UI tool, or we have an CLI tool called Oshinko for creating new clusters. So it takes the name of the new cluster, and also I can change the image. So I'm using my own image because it contains the Parquet file I've just created for the demo. I'll give it some nice name. This, by the way, is the presidential candidate for those who don't know. And if I run get all, I can see that something is happening. I can also go to the web instance, and I can see, yeah, I could have shown that there was nothing there before, and right now there are two. And yes, so there is a master and worker. It also created a UI route for us so that I can go there and see. It's simple. Oops. It's simple monitoring tool for Spark. So if I go there, I can see it's up and running, and there is nothing in there, no running applications. Now I can create the notebook application using heavily overloaded command new app. I will use just my own Docker image, and I'm passing one environment variable that says where the Spark master is running, so I call it Drahoš. I can also check, just to be sure, by Oshinko tool, if it is correct. Yeah, it's correct. So if I do that, it should start deploying the blockchain, the notebook application. I have to expose the root. Actually, it's over here. I can go back to the web UI and see if it is okay. Yeah, it's cool. It's pretty fast, actually. And also check by console. Yeah, it's up and running. So now I can access the notebook. So it was exposed, so I can go to the web URL. So not sure if you are familiar with Jupyter. It's a web-based technology into which you can write a code, and it evaluates the code. And in our case, it will send the code to the Spark master. The Spark master schedules the job on the worker nodes, and we get the results back, and it will display it in a browser. Is it visible? You can make the font bigger and hide this guy. I think it's better. Yeah, so we can check it's a pre-created variable called Spark. If it looks like it's connected to the right master. This is Python, by the way, but it also supports different languages. So here we create a Spark session. That's something like entry point for the further processing. And here we read those Parquet files that were created by the converter. I didn't show this step, but I can show that at the end of the presentation if there is time. It's pretty straightforward. So we load 3 different files, one containing addresses, the other one containing blocks and transactions, and show first or random 5 of them. So as you can see, these are the hash. These are the basically the public keys of the transactions of the addresses. These are the blocks, and these are timestamps when they were mined, and these are transactions. In this command, I will merge everything together and add types to it. So for addresses, I'll add capital A, and for transaction, capital T, and for blocks, there will be the timestamp. It's because the graph frames expect just one big data frame with all the nodes, so that's why I'm merging everything together. In this step, I'm loading the edges, so basically relationships between the nodes. As you can see, there are a number of satoshis that were sent from one address to a transaction if it was an input, or from transaction to an address if it was output. And this is the entry point for graph processing. We create a new graph, giving it to all the nodes and all the edges we have. And now we can run some queries. For instance, here I'm calculating the degrees of each node, joining it with because if I calculate the degrees, it lost all the information. It contains only the ID and the degree. So I'm joining it back to the out degrees and with the original vertices. And for instance, I can group by type, because we have different type of nodes. We have addresses, transactions, and blocks. So I can calculate some basic statistics like average, standard deviation for in degree based on the type. So here we are grouping by type, and for instance, the average in degree, so it means the average number of edges going to each transaction is, or the average case is the 2.9. Its average in degree for blocks is just 1. It makes sense because the only allowed type of node is that can point to block is another block, because that's the relationships between the blocks, like who was my previous block. On the other hand, it can contain multiple output edges, because this denotes the transactions, because block contains transactions. So we have this information here. This is the example of the motif, the language. It looks like ASCII. We are looking for node, edge, and node. And other ones, this TX and this TX are the same. And then we can specify all the conditions we want in the filter parts. The nice thing about it is that it goes through the Catalyst engine in Spark, so it creates optimization before it runs those filters. So it tries to optimize everything before sending on the or scheduling on the workers. So if I run it, what it should do, it's asking for all the edges that participated. It's asking for all the transactions that happened within these years. So I can query using the timestamp and the block information, and also show me only those that were under 10,000 satoshi. It's something like $10 or so. It's not too much, or even less actually, $2 I think. So yeah, these are, but you can type arbitrary query here, and for instance ask, because it's pretty straightforward. We can for instance ask, show me the address who was sending a lot of transactions within a short period of time, and these transactions were relatively small. For instance, if someone wants to hide the fact that he was sending money regularly to someone else. Not sure if you are familiar with the fact that these addresses is not anonymous at all, right? I can see all the data in the blockchain, but I can't be sure who owns this address, who has the private key for the address. The second part of this notebook should show how we can visualize some subgraph, because this graph is really huge. It contains, I should have told that at the beginning, it contains, these were the edges. This is 4 million edges. And it's not the whole blockchain, it's only the small fraction to make it feasible for the demo, because if I load the whole blockchain, each execution would take much more time. But the framework itself supports, it's extendable, and you can run it on bigger data than I'm showing right now. So I've just ran this cell, and what it does, it pre-process or massage the data in a form that is suitable for JavaScript. It's really long. I'm not going to describe all the statements here, but it just creates a small JSON file or hash, if you want, that is then passed to a JavaScript library called Sigma.js for visualizing the graphs. And so this was only the import for the web application. And if I evaluate the cell, I can see that this is the one particular transaction. This is just one input and a lot of outputs. It has so many outputs because here we sorted the transactions according to out degree, and then take the biggest, and some in the first 1,000. Not the first one, but the 80,000, 80,000. We can also find different transaction and plug the number into the previous cell. So here, for instance, we are finding for a transaction that has more than 10 degrees in degree and more than 10 out degrees. And if we've plugged this number to the previous cell, it should change the output. So we can plug some fixed number here. This is the hash of the transaction. And by the way, I can, for instance, take this number, go to blockchain.info. So, sorry for disruption, but I can see that this is a real transaction, and it's shown also over here. And we should get the same information over here. Invalid syntax. That's how I was testing it. Not sure what's invalid syntax. I probably made a typo somewhere. First line. Yeah, it's better now. Yeah, thanks. So if we run it again, it will prepare again the graphical or the JSON data for the JavaScript library, so that we can visualize different transactions here. No, hasn't been done yet. Sorry, takes. As you can see, there is this little star. It means it's still calculating. If there is a actually number right now, it stopped calculation and it received the data from the executors. So if I run it now, it is different transaction with more than 10 inputs and more than 10 outputs. We can also, for visualization, we can also use something called NetworkX. It is a Python library that is used for visualizing the graphs, but it does everything using the matplotlib. So this is the same transaction visualized by NetworkX. I can show the labels. Yeah, but it's really messy. And it also has some way to visualize the transaction using... This is taking a random sample of this fraction of data, of the whole data, and tries to visualize it, so it's pretty random. Yeah, and these are similar visualizing algorithm, but it takes some time, so I'm not going to go through these last two. I've got also a second notebook that uses PageRank algorithm, so let's look at the second one. For this case, I will just use the local hosts because it's easier, and I'm not gonna do the same step as before because it will be boring. So what it does, it just created Docker container with the notebook, and it will run the Spark locally, so it will be a little bit slower but still doable. So this is different kind of notebook. So you are lucky you can see two different notebook technologies today. One was called Jupyter, the first one, and this one is called Spark Notebook. And this time, this is not Python, this is Scala. And we load the data from the Parquet files. And this time, I'm not going to create any joins or calculating statistics. We can see we have 1 million nodes here, addresses. As you can see, the addresses contain some prefix, so I can remove it. That's what this cell does, nothing fancy. Load the edges. And this time we use GraphX, not graph frames, so it's based on RDDs. So we have to prepare the nodes and the edges into the RDD format so that we can instantiate the GraphX with these nodes and edges, which is done right here. Right here. So we create graph, not graph frame as before. And here, this is the most difficult execution or most difficult part. It will just calculate the page rank. It will take, I think, 2 minutes, so I can briefly describe what the page rank is. It's a really famous algorithm. You probably know it. In case you don't, using no mathematics at all is just form of eigenvector centrality measure, and it calculates like intuitively how important the node is when traversing the graph randomly. So what's the probability that you will end up in certain node? As you can see, this node has only 2 edges, but it's quite big, and it's because it's next to this big node that has multiple input edges. So Google uses it for ranking the pages, and it's also it's pre-built in the GraphX library, so that's why I'm using it, because there was no hard work to do it, and it will identify different interesting Bitcoin addresses in our network. So let's see if it is finished. No, not yet. And by the way, this magical number means because it calculates iteratively in each step until convergence, and this says like what's the minimal change that is considered to be different state. So it should calculate for each vertex. It should calculate its rank. Unfortunately, here in this example, we can see that these have probabilities in denoting like how it is probable to end up in the node when traversing randomly the graph. What GraphX does is it will create some magic numbers to those vertices that doesn't denote the probabilities. As you can see, there is something higher than 1. But if you sum all the numbers and then normalize it, it would be same as the probabilities. But we don't need it. We just need to sort the vertices according their ranks. And we can take first 10 and using some helper functions over here written in Scala that would ask blockchain info for fetching more information about the nodes. So I'm a little bit cheating here, but I don't. This notebook doesn't contain the whole blockchain graph, as I said. So this is easier. I've just identified interesting addresses from some short period of transactions. And here I will fetch the more info about the nodes, or just define the functions that eventually fetch the more info. For instance, we have helpers that will transform the bitcoins into dollars. So I should plug in today's value, which is always different. Yeah, it's very volatile. So, and now if I map some get info function to those first 10 and create some nice HTML table from it, we can have some summary of the most significant, according to PageRank algorithm, addresses in our sample data. So and it's clickable link, so that leads to blockchain info. So we can see the first one is, for instance, the mining pool. Today is not as big, but before it was a really big one. Not sure if you're familiar with mining pools. It's a concept where miners aggregate and mine together, and they are rewarded by the amount of time they spent in the mining process. So instead of trying to find the new block itself, which is highly unlikely, they succeed more often by being together, but they will receive less money. So there's the first address, and it was the second one. There is no information about this one. And by the way, we can see that this is the discuss fish or F2 pool. It's because you are allowed to put metadata into the blockchain info. If you are okay with having an address that is publicly known or publicly accessible, you can do that for your address if you need that. It's called tagging the addresses. Yeah, and the last cell will fetch more detailed information, again using some external site. This time it's Bitcoin who is who for one particular address, and this time is exchange. So you can buy Bitcoins there or sell Bitcoins there. This is for the notebooks. I can shut it down. I guess I will be quicker than the deadline. So, what are the takeaways from the presentation? The blockchain is open. If you download the client, it will download all the universe with all the transactions, and you can use the analysis. You can use this framework to analyze transactions, but also to extend it. In Spark, there are two technologies, one called GraphX, the second one called GraphFrames. Both are good for different kind of problems. And I find quite useful to do these experiments in containers, because there can be other party that can leverage your work. It's much easier to run new container with something that someone already does than compiling, and just general thing. And then, this almost tautology, like good representation of data, is always crucial, because in the one network, in the one notebook, I should have told that I use the explicit nodes that denoting the blocks and transaction, and in the second one, when I was running the PageRank, it was just addresses and edges between them. How to get started? I work on a project, as I said, called redanalytics.io. You can go there, and we have this tutorial is also on the website. I would like to also invite you tomorrow. We have booth in front in the hall. Steve Group helped it, if it is here, not sure. And that's it. Thank you. All the code should be here. And this is the code, or this is the link to this presentation. Thank you. If we have time for questions, I guess we have plenty of time. So. Yeah.
I'm sorry, I'm pretty new in this topic, but I want to ask how the mining tools know whether their miners are honest or not. May I simulate some mining and ask some money from the pool without actually mining?
Yeah, so the question was how mining pools know that the miners that participate in the mining pool are honest. I'm not expert about mining pools. I know that there is a protocol called Stratum. It was developed by Czech guy, actually, because all the concept of mining pools was developed by Marek Palanius from Prague. I think there is protocol that you have to first register to that pool. You have some ID credentials, so I guess that's somehow secured.
But doesn't force you to mine, actually.
Sorry? Sorry, I don't know, honestly. I was mining once when it was 3 years ago, using the USB stick in my computer, lately on Raspberry Pi, so just for fun to try it out. I was mining in slush pool, and what I need to do was to register and then run some process, and I was calculating those hash functions. and it was somehow keeping track of how much work did I done. Not sure how it was secured, so I don't know answer to your question, but I guess it was somehow done. And the business model of these mining pools is either that they will get all the fees for all the transactions in the block, or you pay some small fee from your rewards. Sorry, I'm not expert for mining blocks, so I don't know. Yeah, go ahead. Yeah, I know about Hyperledger, but I'm not expert.
There are some discussions internally that
Uh-huh.
blockchain names. I want to know if you follow it and if you are.
My personal opinion is I don't buy this idea, like personal blockchains. It doesn't make sense to me because it's like there's some big bank and they have to have answer for blockchain hype, so they will implement their own blockchain in their seller. It doesn't work that way, right? So I don't know. To be honest, I don't know. But I saw some cool demos for our Hyperledger, but I'm not buying the idea that you can enforce people to use your own technology that you just develop. I know that there will be a presentation about Hyperledger. I will be there, so I'll just be on the audience. Yep. Another question? Thank you.